Today's video will explain the aggregation type of class relation. Hello, I'm James Helfrich. Aggregation is one of the several types of class relations. This one specifically refers to the use of member variables. This video will explain how to represent aggregation with a class diagram, contrast it with composition, as well as describe how to use it in actual code. An aggregate is a whole which has been formed by combining several self-contained elements. One way to think about this is an aggregate is what we make pavement that we drive our cars on. It's a bunch of rocks and sand mixed together with oil and tar and other things to make asphalt. Now, an aggregate class relation means one class owns but may share an object of another class. In almost all cases, it means that a host class has an attribute that is an object of another class. So I have a host class, and here's my class diagram. And now I'm going to have an attribute of type attribute. So now I have another class called attribute, and the relation here is association, which we represent with the horizontal line. But not just any association, this is an aggregate association, and we represent that with a diamond that is not filled. Now, normally what we do is we include numerosity. How many instances of attribute are there in the host class? In this case, there's exactly one. Composition is a special form of aggregation. With composition, the host creates and destroys an attribute. With aggregation, there is no such constraint. By convention, we only use the aggregate diamond outline when the host has only a reference of the attribute. In other words, it does not create or destroy the attribute. So every time a class is a member variable, we have aggregation. The question is, do we have composition or aggregation? So let's take a look at this C++ code. We have a credit card that has a collection of methods. So we have a credit card that has a collection of methods. And now we're going to have a private string. So I'm going to say minus name of type string. Now, since the string is an attribute of credit card, then we're going to have a relation here that is aggregation. And there's going to be exactly one. We're also going to have a type, which is a credit card type. So a type, which is a credit card type. And once again, we have aggregation of one. And then we have a pointer to an account, and that's going to have one as well. By convention, if we're referencing a built-in type or type from a standard library, we don't include that in our aggregation. Now notice, credit card type and account type, they're different. The credit card type, I create and destroy it. With the account, I don't necessarily do so. Therefore, since I do create and destroy the type, then I'm going to make this composition rather than aggregation. Because remember, composition is a special type of aggregation. Let's take a look at another example. With a linked list, deleting one node does not necessarily impact the other nodes in a collection. So what's a linked list? I'm going to have an element 5, and it's going to refer to or point to the next element in the collection, which is 6, refer to the next element, and refer to the next element, and so on. We've represented this in C++ by saying I'm going to have a class node, and my class diagram will have a node. I'm going to have a public attribute called data. I'm going to have a public attribute called data, and I'm also going to have a public attribute called pointer to the next element, pointer to the next element. Now notice if I destroy one node, I don't necessarily destroy all the nodes that it points to. Therefore, my association will be aggregation, which is going to be an open diamond, and there's going to be 0 or 1. 0 if the next node in the collection is a null pointer, there is no node, or 1 if there is one. Here's another example. I'm going to have report class consists of a start date, an end date, a title, and a collection of accounts. So here in my C++, I have a report that has a public method called addAccount and a couple of other ones that I'm going to exclude for the sake of brevity. Now I'm going to have a private attribute called title. I'm going to have a private attribute called title. I'm also going to have a start date and an end date. So I have two attributes, start date and end date. This is of type date. Now, since there are two of them, the numerosity is 2, and since I create and destroy my date when I create and destroy a report, it is composition, not aggregation. Now I'm also going to have a list of possible account. And how many am I going to have? Well, many. Now notice that if I create a report, I don't necessarily create the accounts associated with it. And if I destroy a report, I don't destroy my accounts as well. Can you imagine if your personal finance software destroyed all of your accounts just because you finished looking at a report? Clearly, it wouldn't be the case. Now, the report class creates and destroys the date objects. However, it just has a reference to the account objects. Thus, date is composition and account is aggregation. You can learn more about this in the aggregation section of the Class Design 2 chapter of the Software Design textbook.